In a word, it's opposite to multiplying. You multiplied some polynomials last chapter. A monomial to a binomial to a binomial. Okay? And even going way back when, okay, when you did 4 times 4, what was that, grade 2? Grade 3, you almost had it memorized, your times tables. Okay, that's when you start doing that. That's 16. What are the factors in 16? We prime factorize that thing. This is factoring. It's going backwards. Can I break that down into 4 times 4? Yeah. Could I break that down into 2 times 2 and 2 times 2? Yeah. Okay, that's factoring. It's the opposite of multiplying. Or the other word for multiplying is expanding. So I could write 16 as 2 times 2 times 2 times 2. Okay, or 2 to the 4th power. What's the 4th root of 16? We're all kind of saying the same thing numerous different ways, aren't we? What number multiplied by itself 4 times is 16? That number is 2. Okay? So, common factors. It's going to get really tricky, guys. Okay? But first things first. I just said that. We've done it. How do you multiply this to that thing? You have brackets. You have to multiply it by everything in the brackets. Okay? So that's 2x squared plus 2x times 5 is 10x. Okay? Binomial times a binomial. Expand it out. How did you do this? Did you do FOIL? Did you do your little area diagram? Or did you, take the long way and actually make algebra tiles? Okay, I don't think I saw anybody do that in the midterm. FOIL's how I'm going to do it. Okay, so again, if you do area diagram, that's fine. Okay, keep doing it. First times first is x squared, right? Oh, let's write it. Outside, x times 3 is 3x. Where is it? Right here. Okay? Inside, x times 1 is x. There it is there. And then last is 1 times 3 is 3. 1 times 3 is 3. Add up all 4 things. Add up all 4 things. We get the same thing. I can collect 3x and 1x. That's 4x. Okay? And here I can collect those and get 4x. I should get the same thing, right? Okay. Same deal, just a little bit harder. 2x squared outside is 8x. Inside is 3x. And last is 12. I got my 4 terms. They're just a little bit bigger because this wasn't just an x, it was a 2x. Okay? And then if we get a special kind of one, a binomial times a binomial, these simplify down to give me trinomials, right? 3 terms. 3 terms, because I'm going to collect those and make that 11x. This guy's special, because what happens? X squared plus 5x minus 5x. How many x do I have? What's $5? I spend $5. I got no bucks, do I? And negative 5 times positive 5 is minus 25. So when I simplify this guy, my x term disappears. Okay? It's gone. It's canceled out. There's a word for this in Math 11. We don't need to know it yet. Okay? You just FOIL it like you do all the other ones and simplify it. And yeah, we get 2 terms. Okay? We don't need to worry about that, what that is right now. Okay? So a little bit of review. We got to know this stuff, guys. We got to be good at this stuff. Okay? So, these were expanded. These were multiplied. The opposite process, I said it on the top, that's called factoring. How do I go from this to there. That's what we're going to be doing. Does that look kind of hard? It will be. Okay? So, complete using the results obtained above. Let's factor this by removing a common factor. So you look at your two terms. What's common between this one and that one? That's what we're going to remove. Okay? It's the opposite of multiplying. So declutter your brain. Just look at the numbers. What's common between 2 and 10? Is there something I can divide both of those things by? 2 goes into 2. 2 goes into 10. Okay? What do I have left if I take a 2 out of here? I'm going to have an x squared. Okay? What do I have left if I take a 2 out of 10x? I'm going to have a 5x. Okay? I'm factoring by removing a common factor. I'm not done yet. All I did was the number. There's still a common factor here with the x's, isn't there? Okay? I'm going to do this in 2 steps. Now, can I check to see that this is the same as this? Because if it's not, I made a mistake. 2 times x squared is 2x squared. Okay? 2 times 5x is 10x. This is the same as this. I didn't change it. Now, it's not fully factored because, like I said, I still have something common here. What can I take out of an x squared and a 5x? I can take out an x. So I still have my 2. I'm going to take x out of x squared. What do I have left? An x. I'm going to take this x out of this 5x. What am I going to have left? Just a 5. Okay? You keep factoring until you can't factor anything else. Is there any more common factors in x and 5? Then I'm done. Could I check to see this is the same as this again? What's 2x times x? 2x squared. 2x times 5? 10x. And remember, didn't I already do this? There it is. Okay? Yeah, this way's easier, multiplying it, but we got to factor it. We have to go back the other way. Okay? This we won't be doing for a few days. But it's the same thing. If I have a trinomial, how do I convert that into 2 binomials? What do I multiply these by to get that? Okay, so we're not here yet, but think. What times what is x squared? That's got to be x times x, right? That's the first part. When I FOIL this, that's what I get. Skip over here and look at the last thing. What times what is 3? You only have one choice, right? It's got to be 3 times 1. Now, how do I put together my signs so that this works? Well, it's plus plus. You only have one choice. It's probably plus plus. Then you check it. Is that x squared plus x plus 3x? Is that 4x? Well, we're getting pretty good at foiling our polynomials, right? And 3 times 1 is 3? Yes, it is. Okay, so like I said, we're not doing that today. That's where we're getting to. Okay? This thing is called a difference of squares. Difference minus sign, that's the square of x, and that's the square of 5, right? So I'm not even going to bother looking at that. Okay, so what I did with the first one, this is what we're going to be doing today. Greatest common factor. We know what this is. We've done it before. Okay? That's what you look for. So again, a little bit of review. The greatest common factor of 48, they just prime factorized this, right? But we just didn't do it like a tree, okay? I didn't go, 4 times 12, and that's 2 times 2, and that's 4 times 3, but that's also 2 times 2. Okay, they just took all these numbers and wrote them down there. 48 is 2 times 2 times 2 times 2 times 3, right? 2 times 2 times 2 times 2 times 3. 72 is divide it in half. Take a 2 out. I got 36. Take another 2 out. Now I got 18. Take another 2 out. Now I got 9. And 9 is 3 times 3. So if you're pretty good, you can kind of do it in your head. But hey, if you got to do it that way and then write them out, then do it. They're just trying to save space here, right? Okay? So again, how do I find the greatest common factor? What's the largest thing that goes into both of those? Well, you just pair them off. I got a 2. I have another 2. There it is. 2 times 2 times what? Got another 2. And I have a 3. So the greatest common factor is 2 times 2 times 2 is 8 times 3 is 24. That's the largest number that goes into 4872. Okay? Now it's a little trickier when we get these things, but again, we've done this with variables. Okay? How do I prime factorize 6a cubed? Just look at the numbers. 6 is 2 times 3, and a cubed, that's just 3 a's. Okay? 9a squared b, 3 times 3 times a times a times b. So the greatest common factor, what's common? 2? Nope, don't have a 2, but I have a 3. I have an a. Okay, do I have anything else? Yes, I have another a. Anything else? Nope, that's it. What's 3 times a times a? 3a squared. That's the largest thing that goes into both that and that. Okay? So before we show you a little bit of a shortcut, okay, write the prime factorization of this and that, and determine the greatest common factor. Okay? Well, let's do it. That's 4 times 2, which is 2 times 2. I got x and an x and a y and a y. Okay? So 8x squared y squared is equal to 2 times 2 times 2 times x times x times y times y. 20xy cubed is, take a 2 out. What do I got left? 10. Take another 2 out. Now I got a 5. Okay, so is 20 2 times 2 times 5? Yeah, that's 4 times 5. Those are all prime numbers. I got 1x. I got 3 y's. Okay, so my greatest common factor is 2 times 2. No more numbers. Have an x. Okay, nope, no more x's. Got a y. And I have another y. And that looks like it. Simplify it, that's 4xy squared. Then double check it in your brain. Does that look like the biggest thing that goes into both of these? 4 is the biggest number that goes into 8 and 20. I can't have anything bigger than an x because that's the lowest thing here. And y squared, I can't have anything bigger than that because that's the lowest thing here. So looks fine to me. Okay, so that should work every time. Took about 8 seconds, but I think it was well worth it. Here's a little shortcut. Everyone loves shortcuts, right? But sometimes we make a shortcut and then we, of course, don't even get the answer, right? Right? The greatest common factor of 2 simple monomials, that's what these guys are, okay? Monomial, can be determined by inspection. Take the GCF of any numerical coefficients, that is, just look at the numbers, okay? And then multiply that by the common variable to the lowest common exponent, okay? What's all that in plain language? Okay, The greatest common factor of this monomial and that monomial, first just look at the numbers. What's the largest number that goes into 10 and 15? 5. Okay? Then look at the lowest common exponent. Look at the p's. Which one's smaller, p squared or p cubed? P squared. Just look at the q's. Which one's smaller, q or q squared? Q. So that's my greatest common factor. 5 times p squared times q is 5 p squared q. Okay? So maybe I shaved off about 4 seconds. That's precious time, guys. What could you do with that? Send half a text message? I'm being sarcastic, of course, right? Is it a shortcut? Okay, sure, right? But if this is the way we need to get the mark, that's the way we should be doing it, right? Okay, so let's use our shortcut. What's the greatest common factor between this and this? Just look at the numbers. Between 12 and 15, what's the largest number that goes into both of them? With 3 and 4 and a 6, which one goes in 15? Does 6 go in there? No. Does 4? No. 3 does. Okay? And then what's smaller, a or a squared? A. Which one's smaller, b or b cubed? B. You're done. All right? We're not going to do negatives. Change that to a positive. Okay? I'm not here to confuse you. What's the largest number that goes into 18 and 24? Anybody find anything bigger than a 6? No, the only thing bigger that goes into 18 than 6 is like 9 and 18. Neither of those goes in here, right? Okay? All right, which one is smaller, x to the 4 or x cubed? X cubed. Which one's smaller? Where's my highlighter? Y squared or y to the 5th? Y, whoop, you can't see that. Y squared. Okay, you're done. Okay? So, don't worry about that, don't worry about that. Actually, let's do that one because that one's got a few different variables. Okay. So what do we do? Just look at the numbers. What's the number here? Yeah. Okay. So the numbers 1 and 2, what's the greatest common factor? It's 1. 2 doesn't go into 1, right? So if you want to write it, great, but you don't have to. Okay, I got an a cubed and an a. A is definitely smaller. I have a b. Do I have a b over here? No, so I can't use it. It's not here, right? I got c squared and c7. Smallest is c squared. So that's the greatest common factor. Okay, that's the biggest thing that goes into that one and goes into that one. Okay? Don't think, some people say, well, what have I got left over? Don't think that way. Okay, it doesn't help you, right? It doesn't help you. I know this goes into that. How can you be sure? Because if I put it underneath it, it'll be gone. That'll be 2. That's gone. I don't care what I got left over. This is now gone. Therefore, it went into it, right? It got divided into it. This is divisible by that, okay? Nobody likes the big word, right? Does that, that's supposed to be 7, go into this? Yes, it does. It goes in there. It goes in there, okay? That's what I have left, but this thing is gone. Okay, it got divided into it. Okay, so why are we doing that? Because when you find the greatest common factor, that's this thing outside the brackets. Okay, the greatest common factor between this and this is 4xy squared. That's what's outside the brackets. That's what you divide out of both of these two terms, and this is what you have left. Okay? This is fully factored. I can multiply it or expand it back to get that again. Okay? That's why we're doing greatest common factor. All right? Factoring's the opposite of multiplying or expanding. So, complete the following. Complete the factoring, same thing. Okay, we're helping you here. We're telling you like what to do. We're just asking you what's missing. What did I take out of this? It used to be 21x, now it's 3x. What's 21x divided by 3x? Yeah, looks like they took out a 7. Okay? But don't just like go on to the next question. Check it. Is 7 times 3x 21x? Check. Is 7 times 2y 14y? Check. It's got to be the same thing. If it's different, that means you changed it, and that's wrong. You can't do that. All right? There's an x squared. It used to be 5x to the 4th power. What must they have taken out? A 5, definitely. And how do I get from x squared to x4? Times it by x squared. Okay? That's the greatest common factor between these three terms. Double check it. 5x squared times x squared is 5x4. 5x squared times 3x is 15x cubed. 5x squared times 1 is 5x squared. Is this the same as this? If it's not, we got a problem. You can check every one of these. This whole chapter, factoring, you should never get one wrong. Because you can always check to see if you got the same thing. Okay? In each case, the greatest common factor has been removed. So now they took out the greatest common factor. You got to figure out what's left. Okay? 5a times a is 5a squared. What is 25a divided by 5a? 5. Okay, that's what it's saying. Double check. Is this the same as this? Yes. 5a times 5 is 25a. All right. If I take a 2 out of 18p, what do I got left? 9p. Okay? And they took 2 out of 16q, and they got 8q. So you can use the word take out. Okay? Kind of sounds like fast food. Or divide. What is minus 4mn divided by minus 2m? Is that too much for your head? Write it out. Negative 2 goes into negative 4. Negative divided by a negative, that's a positive. 2 goes into 4 2 times. M divided by m, it's gone. I have an n left. And then double check it before you even go on to the next number. Is this times this equal to that? Negative 4mn. Yes, it is. Check. Okay. Negative 2 times what is negative 6m squared? How about 3m? That's company. Okay. Negative 2 times 3 is negative 6. And m times m is m squared. Double check it before you go on. Okay? So let's repeat what we're doing again. We want to factor this. What's the greatest common factor of these two terms, it's minus 2m. Okay? What's the greatest common factor of these two terms? Actually, these three terms? They're telling you it's 9x. If I take 9x out of 18x squared y squared, okay, just look at the numbers. How many times does 9 go into 18? 2. How many times does x go into x squared? X times. And I don't have a y squared term, so I better put it there. Okay, next term, minus 9 goes into 45 5 times. X goes into x once. And I don't